Rahim. In today's video session we will learn about series and parallel combination of resistors. As we know, in series combination of resistors or resistance, the current across each resistance is the same. However, in parallel combination, the voltage across each resistor is exactly the same, but the current flowing through them are not the same. If multiple resistors are connected in series, you can simply sum up and find the R equivalent resistance. So the equivalent resistance of any resistors connected in series is the sum of the individual resistances. So you can sum of all the individual resistances and find the R equivalent resistance. If multiple resistors are connected in series, so you can sum up all the individual resistances, that is R1 plus R2 and so on. In parallel combination, as we know that the voltage across each resistance in parallel would be the same. So the R equivalent resistance of two or any resistor connected in parallel is equal to the product of their resistance divided by their sum. R 1 over R equivalent is equal to 1 over R1 plus 1 over R2. Let's suppose how so R equivalent would be equal to R1 R2 divided by R1 plus R2. So the product of their resistances divided by their sum. Conductance is comparatively we can say the reciprocal of resistance as conductance. So you can reciprocal this. R equivalent is equal to R1 plus R2 in series, and parallel this the reciprocal of R1 is, you can write 1 over G1 plus 1 over G2 and so on. And series you can write G1 plus G2 and so on. As we know, G1 is equal to 1 over R1. So after putting this value here, this would become 1 over R equivalent equal to 1 over R1 plus 1 over R2. So this is exactly the same as we have in R equivalent in parallel. So conductance is the reciprocal of resistances. So how can we find that two resistors are connected in parallel or in series? For any resistance we have two ends like A and B. Let's suppose it's AB and R1. For other resistance we have two ends A and B, R2. If you connect them like this, A and B, if you connect A with A and B with B, so we will consider this combination as a parallel. And if A and B are one, only one end is connected with the other, so we will consider this combination as a series combination, and the other two ends are connected with some other element or some other resistance. So you can easily find that two resistors are connected in parallel or in series. If both the ends are connected with each other, then those combination will be considered as a parallel combination. If one end of two resistors are connected with each other and the other two ends are connected with some other element or some other resistance, so this combination will be considered as a series combination. So as we know in the previous lecture we studied nodes. After watching that video you can easily find that how can we connect different branches in a node form. So let's solve an example from book Fundamental of Electric Circuit, example 2.9. So in a circuit we need to find R equivalent. So start from the most complicated part of the circuit. So the complicated part right now is looking 6 ohm and 3 ohm resistors. So as these two resistors are connected in parallel, how these two are connected in parallel? Because we don't have any element here, and we don't have any element here. So this is a side or B side, we can say A side and B side, so both the ends are directly connected with each other. So that's why 3 ohm is parallel to 6 ohm, or we can say 6 ohm is parallel to 3 ohm. So for parallel combination, you can product the two resistance divided by sum of the individual resistances. So product is 6 times 3, and then you can simply sum of, so 18 divided by 9 and 2 ohms. So now we have, you can simplify the circuit, 2 ohm, and you can write 2 ohm for these two circuit. 5 ohm, 1 ohm, 4 ohm and 8 ohm. As we know, now 2 ohm and 2 ohms are connected in series because A, B and A and B, because only one end is connected with each other for the two resistors. So 2 ohm and 1 ohm, 2 ohm plus 2 ohm equal to 4 ohm. So you can simply write, you can simplify the circuit, 4 ohm, and you can write here 4 ohm, and we have 8 ohm, 1 ohm and 5 ohm. As we know, 1 ohm and 5 ohms are connected in series because only one end for both resistors are connected, and the other end is connected with some other resistor, that is 4 ohm. So this will become 1 ohm plus 5 ohm will become 6 ohm. So now the reduced form of the circuit will be like this. We are reduce this to this, and now 4 ohm and 4 ohm, this is 8 ohm, and now we have 6 ohm. Now 4 ohm and 6 ohm are connected in parallel because A is node is connected with A and B is with B. We don't have any other element in the middle. So 6 ohm and 4 ohms are parallel. So you can simply multiply 6 with 4 divided by 6 plus 4. So 24 divided by 10 equal to 2.4 ohm. So 2.4 ohm. Now the reduced form would be like this: 4 ohm, after this 4 ohm, we have 2.4 ohm for these two resistors and 8 ohm. Now you can see that all these resistors are connected in series, so you can simply sum up and you can find R equivalent. 4 plus 2.4 plus 8 equal to 14.4 ohm. So this is our R equivalent resistance for the given circuit. Now you can easily solve any combination, any combination of resistors or that are connected in parallel or in series. Now let's solve another example that is a bit complicated comparatively to the previous one. So we are going to find the R equivalent resistance across A and B node. As we know, you should solve the most complicated part of this circuit first. So in this way, 3 ohm is parallel to 6 ohm. How? Because one end is connected here, A, with each other, and the other end is also connected with each other because we don't have any element in the middle. So A and B, because this is B, so these two are connected with each other. So the 3 ohm is parallel with 6 ohm. So 3 ohm is parallel with 6 ohm, so you can simply multiply and divide it. This 18 divided by 9, and you can get 2 ohm. Similarly, 12 ohm is parallel with 4 ohm, because one end is connected here, A, and we don't have any element in the middle, so both ends are connected with each other. So 12 ohm is parallel to 4 ohm, so you can simply multiply and then you can simply divide by summing up the individual elements, and this way you can get 3 ohm. So after solving these, you can write the reduced form of the circuit, and you can draw the reduced form in this way: 1 ohm, and this here we have 3 ohm, and for these two you can write 2 ohm. 2 ohm, 3 ohm. And as we know, 1 ohm is in series with 5 ohm, so you can simply 1 plus 5, 6 ohm, so you can write 6 ohm here. Now again, as we know that 3 ohm is in parallel with 6 ohm, so 3 times 6 divided by 3 plus 6, 18 divided by 9, so you can get 2 ohm. So 2 ohm, and after getting 2 ohm for these two resistors, the 2 ohm is in series with 1 ohm, so 2 ohm plus 1 ohm, 3 ohm, so you can get the reduced form like this: 2 ohm and 3 ohm. And this one is 10 ohm, and again these two resistors are in parallel, so 2 times 3 divided by 2 plus 3, 6 divided by 5, so 6 divided by 5 equal to 1.2 ohm, and 1.2 ohm is then in series with 10 ohm, so 10 ohm plus 1.2 ohm, you can get 11.2 ohm. So for this particular circuit, R equivalent equal to 11.2 ohm. Now you can solve any kind of circuit for R equivalent. Thank you.